Welcome to LNP Renewable System Integrator. Today we are going to discuss some of the basics about the air velocity sensors. So if you are going to work in abroad like GCC, UK, if you're going to work in a building automation field, or if you're going to work in a heat ventilation air conditioning systems, you should be pretty aware of these air velocity sensors. Okay. So what are the things that we are going to discuss today? So today we are going to discuss what is the air velocity sensor, where can I see this, okay, where can I use this air velocity sensor, how it looks like, how air velocity sensor works, how air velocity sensor is wired and installed, and what are the things as a building management system engineer or a technician, a building automation control system engineer or a technician I should know in the air velocity sensors. So basically air velocity sensor is nothing but one of the variable that can be measured, okay, with degree Celsius, lines of intelligent flow show sensors. In addition to the airflow, with the help of these airflow sensors, we can measure the temperature, humidity and the pressure also. Okay, this is commonly used in heat, ventilation and air conditioning systems. Why we want to use this air velocity sensor? It's very simple, because if you're going to use an actuator in an air handling unit or in a variable air volume unit, for sure we will be using the damper actuators. So in order to control the damper actuators, the basic step, the first step is that first there should be airflow. If there is no airflow, there is no use of operating these dampers. So for controlling these dampers, airflow is very much important thing. So in such places, in such applications, we are using this air velocity sensors to measure the flow. So where can I see this? So if you are going for a multi-storage building, or if you are going for a metro station, or if you are going for an airport, you can watch these air velocity sensor inside the air handling units and variable air volume units. Even in the fan coil units also you can see these flow sensors. Okay, so it is used in all the indoor as well as the outdoor places where the airflow is very much important. Even for the track exhaust fans, pressurization fans, staircase fans, tunnel ventilation fans, air handling units, we can use this air velocity sensors. So even the air handling unit, this is the most important device. See here, today we are going to see in detail about a sensor, particular sensor, because there are so many companies you are using this air velocity sensor. Today we are going to discuss about the air velocity sensor of Siemens. Okay, this is an example, the real photo of the air velocity sensor of Siemens, and even we have other companies as well, but today we will discuss about the air velocity sensor of the Siemens. Okay, see here, room temperature, how the room temperature inside a particular building is maintained with the help of air handling unit, and how airflow is very much important. So this is an example. See here, we have a airflow sensor based on that actual, and even we have a set point for the airflow also. So in order to maintain the set point airflow, first we need to know what is the airflow. So with the help of the airflow sensor, we are measuring the airflow. It will be in the meters per second or cubic meter per hour. Okay, but based on in order to maintain the set point airflow, okay, inside the duct or inside the building, we should know the airflow. So for that, to measure the airflow, we are using this air velocity sensors. So this is the wiring diagram of the air velocity sensor of the Siemens. See here, you have a terminals. These terminals, we will connect the wires which is coming from the field side immersion stem, which is installed inside the duct. Okay, and these are the terminal which we are going to connect with our controllers. Okay, so it depends, it changes based on the configuration that we are going to use. It means if you are going for a 4 to 20 milliamps, the connection will be different. If you are going to go for a 0 to 10 volt, then the connection will be different. Okay, so as we told earlier, with the help of this motion stem, we can measure the air velocity. It will provide the electrical signal inputs in these terminals. Okay, and settings we can make on our own, because we have a range. We can set 3 different ranges in the sensor. One is the measuring range can be from 0 to 5 meter per second, or it can be from 0 to 10 meter per second, and the third one, it can be from 0 to 15 meter per second. So in these three configurations we can configure with the help of these jumpers. If there is no plug-in jumper, it means its default setting is 0 to 5 meter per second. If the jumpers are plugged in 1 and 2, then the measuring range will be from 0 to 10 meter per second. If the jumpers are installed in 2 and 3, then the measuring range will be 0 to 15 meter per second. Okay, and even for the dip switches settings also there. If you want your output in the current, it will be 4 to 20 milliamps. Okay, and if you want your output in the voltage, then the dip switch should be in the U. It will be from 0 to 10 volt DC. Okay, and most importantly, we will all have a doubt where we have to install this sensors in the duct. That is a critical question we all have. Very simple. We should install it, if you go by the lengthwise. Okay, it should be we should keep in a distance of 6 times its dia of the duct. We have a circular duct. Okay, it can be flat duct. If you're going for a circular duct, it means after the 6 times its dia. Say for example, the diameter of the tube that you're going to use is 3. Okay, so 6 times its dia, 6 into 3. So at the 18th meter from the bend, you have after the bend you have to install 6 times its dia. So at the 18th meter you have to install the sensor. And most importantly, if you're going for a flat or rectangular ducts, in the 1/3 of its height you have to install the ducts. It should be immersed. Okay, the immersion stem should be at the 1/3 of the total height of the duct. Okay, and most important notes that you need to keep when you are installing the air velocity sensor, that you should not install near to the dampers, registers, and you should not install in the duct direction changing locations, because in those places the velocity will be more. So you should install in a location where the airflow is quite normal. Okay, so this is an example of a variable air volume unit in which the air velocity sensor is being installed. So this is getting directly connected with the damper, because the damper actuator decides its opening and closing function basically based on this air velocity sensor, because we might have set some set point that if there is an air velocity this much, then only it should open. If there is no such air velocity, then it should not open. So like that, that controls we can set in the controllers. So for that functioning, basic functioning of the dampers, we are using this air velocity sensor. This is an example of the air velocity sensor which is being used in the VAV terminal units. So as we told earlier, we can install in wherever the airflow is there. See, even the air units like ducts, air handling units, we have a supply fans. So we are running it with a variable speed motor. So we are controlling the motor. We have a controlling units, but based on the control set point, you need to maintain the air velocity. So in order to know the air velocity, we need the air velocity transmitters. Okay, it will be installed like this. Even in certain places like conveyor, dryer, ovens also, we can use the air velocity sensor. So we can keep the set point in the controller, so that based on the input from this air velocity sensor, the actuator will operate. Okay, it will enable the air supply. Okay, as we told earlier at the starting of the session itself, with the help of this air velocity sensor, we can even measure the temperature. It can also act as a temperature transmitters in certain places. So the one that we saw is the only air velocity sensor. There are sensors which has all the features like temperature measuring, humidity measuring, pressure measuring. Okay, we can enable those options if you go for such sort of sensors. So most importantly, the basic function behind this normal air velocity sensor is pitot air velocity, because it is like a pitot tube. Okay, it will have a two tubes installed in it. There will be a liquid inside it. It can be a mercury. Okay, so the positive port of the manometer can be connected to the total pressure port, and the negative can be connected to the static pressure port. Okay, so it will display the air velocity, which can be converted into velocity. So first we need to know what is a manometer. Manometer is nothing but a device which, using that, we can measure the pressure of the pipelines. It can be a gas, it can be a water, it can be liquid. See, this is an example when there is an airflow. See how changes are happening inside the pitot tube. Okay, this is also another example Okay, analog meter, how it is working. So as we told earlier, in the air handling units we are using the flow transmitters. It can be a flow sensor as well. Okay, see here in the supply line and the return line, this is an example of double supply double extract type. Here in the supply and the return line we have the flow transmitters, and in the second part if you see we have a single supply double extract. So here also we have the flow transmitters, and the third one double supply single extract type also we have a flow transmitters, and the single supply single extract type also we have a flow transmitters. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details here. If you want to do projects with us also, you can contact us. So if you are a diploma student, you are an engineering student, you are in electronic engineering branch, or you are from electronic instrumentation branch, or you are from electronic and communication branch, if you want to work in a automation industry, basically heat, ventilation, air conditioning system industry, you can contact us. If you are planning to work in GCC or getting a chance, you want to know what are the things that I'm going to use in a heat, ventilation, air conditioning industry, how I can program and maintain, establish an automation inside a building with the help of this PLC controllers and the SCADA. If you want to know the basics, we are providing the training with the certifications, and we are also providing the consultancy supports also. So you can contact us. We can provide the contact details. We are also providing solar on-grid, off-grid and hybrid application design, installation, testing and commissioning support. You can contact us. If you want to know more regarding the electric vehicle basics, also you can contact us. We are providing all these courses with the certifications, so you can contact us. Thank you so much.